Hello all. Uh, I'm making this video just to show you some basics about the software COMSOL 5.5. And this software, we were given the task about to make a 2D geometry with Laminar Flow. And the geometry should be 2 by 3 millimeters square in area, and they have union, and they have fully developed flow rate with 0. Mu L per second, and the side port velocity of 0.05 mu L per second for the inlet. So you can see this by stopping the video anytime. What are the questions and what are the points we have to cover in this assignment? So let's just start. I already have made some new file already for this. Just to show you how to start is that you must have a model wizard in 5.5 software, and then you create select 2D, because the task was given just to make a 2D geometry, so we have just to select 2D. And when you select 2D, things will appear like this. And here you have to select laminar flow setting and just click add. And then one more thing you have to add is after this is study. So this take a little bit time, we have to wait. Yeah, now it's done. So the next thing you have to add is a study. And when you click on this study icon, then you have two types of study, like stationary or time dependent. But we have to select study stationary, and then we have to select done, and then we have to wait a little bit. So now everything is done. So the window will appear like this, and here we have options like parameter, definitions, geometry, and material, laminar flow, which we already have selected. So the thing is, I have already done this assignment before, so I will just open the new file, my file, which I have already done. And yeah, yeah. Here you can see I have made a geometry with three inlet and one outlet. So the thing is, we just have to first define parameters, what kind of parameters we are using. So like I am loading radius for red, I made only red, and then we have x0, y0. These are the initial positions, and x1, then hnum. These are just my, you can say, for my, to make it more easy, more what can I say? Yeah. So now we have to make a geometry. So for the geometry part, we go to components and we have geometry here options. So first of all, you have to make the geometry scale unit, or you have to select the scale in which you have to measure, in which you want to make a geometry. So like there I have used millimeter, because in my assignment I was given to make a geometry which is in millimeters. So I've selected it here millimeter, and then I made a geometry. So you can generate a geometry by just clicking right click on this geometry icon, and here you can see rectangle, ellipse, circle, whatever you want to make, then you can make likewise. You can choose likewise, or there is also a geometry tab. Here you can go to geometry and then sketch, and under sketch option you are able to draw it like this. You can select rectangle and then you can draw. Yeah. So now I will not draw anything because I have already drawn. So the thing is, now we can move this part, and here I select all the five rectangles, not five, these are four rectangles, one, two, three, four. And in the end I have just deleted this part, this inside part, means the interior boundaries for this. This is because I don't want to include the interior boundaries between these. So then I just make union, and then this geometry is all done. The next part is to we have to add a material. So when we go to material, then we can right click it and add material from library. Then when you add material from library, then you can have click on add material from library, then you can be here and you can see or what kind of material you want to add. So you can write water and then search, and then it will take some time because this software takes some time to, because this is a very big software. As you can see, there's 934 MB per 1161 GB. So this takes some time. So yeah, here it is ready, and you can see the water material. You just have to click on it, water, and then add to component. Then this will appear like this. And in water, when you click this, all these two must be checked. This is the initial basic things that must be checked already, and now you have to select what and which you want to flow the water. So I just made five rectangles with this, the bigger one and the four inside. So I want to make flow here inside. So I just selected it by, when you do this, you can unselect, that means you cannot select anything, but when you press this, you can select things like this. One, no, this two. Yeah. Then I want to add flow here, so I just selected this area. Then we go to the laminar flow settings, and there we can find where we have to flow, make a laminar flow. So I just edit like previous. I add the boundary for the laminar flows. The boundary is this boundary, this figure that I have already made. So this figure is here we where we want to flow, see, or where we want to see the laminar flow. Yeah. So oh, I already selected this. So now in here you can see many things: p reference, e reference. So this keep as it is. So now in description uh, we were asked to make it to P2 plus P1 because we were given the task to change it to P2 plus P1. What is P2 plus P1? This is here. This will split the complex variables abstraction. So this is where we can find in the description box, and in the description box you can see there are many p1 plus p1, p3 plus p2. Likewise, just we have to select p2 plus p1. This would be good. And then the fluid properties is you can see there is nothing to change. One is not applicable as I have not selected that area. And in the initial values you can just do nothing, and then yeah. Then you have to add three inlets because we were asked to make three inlet and one outlet. So when you right click this inlet, you have to select three times and one outlet. So this is inlet, and here we were asked to fully develop flow rate with 0.1 mul per second for each side port. So here we just select fully developed. Before it was just selected velocity, so now I add flow, fully developed flow, and then in the fully developed flow I add flow rate. In the flow rate I add velocity and diameter thickness, entrance thickness, sorry. So that the thing is SG1, here the SG1 are linked already with the parameter we have defined before, and the parameter is SG1. This is side port 1 with velocity of mu1 mu per second, that is already given in our assignment. So I just what I have just say in inlet 1 this is SG1, and with the thickness this is already we were asked to make it the thickness like this 100 micrometers, so I just put the number here, and here I put just SG1, and here I select the inlet 1. This is the inlet 1 I just selected. Likewise for inlet 2, I just selected this part, and for that same thing follows. Flow fully developed, flow rate, and the velocity should be SD2 now, and diameter thickness will remain the same. Now the third part is inlet 3, and inlet 3 is the fourth one, fourth border, and this is just the same, but the inlet velocity is third inlet velocity is a little bit different, I think so, because we here is where the flow comes in. So this is 0.05 mul per second. So this is a little bit different, and for the outlet we just need to mention or select only the border which is going to where the liquid will outflow. Yeah, so here we just select pressure, and then we come to the mesh part, and then when you come click the mesh part, you just have to make it build all, and then this is done. Then you go to study, and then you just need to compute the study, and this will take some time. Yeah, here you can see the flow. Here's the flow rate, and here's the velocity. Here's the inlet where the sample is was in, and here are the two side port inlets velocity. This is the diagram is different. Here you can see by clicking on this, and yeah, here you can see the velocity is different, and here the velocity is different, and here the velocity is different. And this is because we have selected three parameters, like I have already told you, sg1, sg2, and sg3, and these are both the same, but here is the velocity is a little bit faster because this was 0.05 mul per second, and here is 0.01 mul per second. So this is all done here up till now. Then you have to make a graph. So for the graph you have to define cut line 2D. So how can you define cut line 2D? When you go to results, no, when you go to datasets, there you can find cut line 2D, and then when you select this will appear like this, and just you have to do is to define the points where you want to plot where we want to see the cut line 2D. or you where you want to see or plot the graph. So we were just asked to make the to show the velocity at the cross section and at the out at the end of the channel. So I just select 1, 1, and 1.3 and 1.6. These are just the points to make this cut line. For cut line 1, 2D1, and for cut line 2D2. Here I have selected the graph points. This is 1.6, 1.6, 1.4, and 1.6. And don't forget to add in dataset the solution from study 1. This will link your cut line to the study 1 solution. And then what you have to do is you have to go to results and make 1D plot graph. And when you click this 1D plot graph, then the things will appear like this 1D plot graph. And in the 1D plot graph, you have to select line graph, line graph 1 and line graph 2. How can you select this? Just click line graph one time and this will come like this. And then you have to, what you have to do is to link this line graph to cut line 2D1. And when you do this, and this will all be linked with the line 2D1, and here you can change the expression, means this the parameters, like I want to see the plot graph for velocity on y-axis, and on x-axis this is the arc length or the width of the channel. Similarly, for cut line 2D, you have to go to line graph 2 and make cut line 2D. Select this cut line 2D, and similarly, you have to select SPFU. This is your velocity, and this is your arc length. And then you just have to plot, and all the thing is done. You can see the graph. So here's the video for lecture 1 or assignment 1. Hopefully you have understood all my things. Yeah. Thank you.